Hello, today we shall be developing panel unit root model, and here we have 6 countries and the data is for 10 years. So that is the data. So the data is here. I can show you my data that is here. You can see the data. The data is here. All the data is here. Okay. So here I can open the data as a whole. You can see the sample. So data, I can open all the data at a time, and make sure this one is the cross section data. So I open it as a group. Data is here, right? Data is here, you can see. So the data is here dated, and there are 3 variables: export, GDP and import. And here you can see there are just 1 minute. I think I need one more data. You just hold. I'm taking it out. It is not here. Okay, I cancel it. I open it again. Just 1 minute. Import cross. Okay, I need to open it as a whole. Why not coming? Okay, open. Then I also open all at a time. Okay, the data has opened all the data at a time. You can see from here, right? So there are 6 countries. So you can see all the country are here. It is country 1. It is until data 2000 until 2010. That is the data for country number 1. Then country number 2 also data from the year 2000 until 2010. So that is for second country. And what about third country? It is starting from here until here. That means 2010. Again, data from country 4 starting from 2000 until 2010. So there are 6 countries. So you can see data from 2000 until 2010. So this is my data. You can see the data, and I have 3 variables. One is export, GDP and import. There are 3 variables are here for each country for 10 years each. Okay, now I shall check. I have 3 variables. Which variable has unit root or not, right? That means how to detect unit root in this panel model. Okay, here are 3 variables. So out of 3, I show you only one, that is GDP, and the rest you can do because the procedure will be same, right? Okay, so here what I am doing actually, what I do, just 1 minute. Okay, here the GDP I shall detect whether GDP has unit root or not, that I want to check only, right? Okay, how to proceed about it? Okay, so how to proceed? Then I have to go to quick, then I go to series statistics, then unit root, that I select from here, I click, then I put GDP here. I put GDP, you can see from here, right? Then I press enter. Okay, sorry, not enter. I press OK. Okay, here you can see the result has come up. Okay, actually there are many methods. Suppose I click on the summary, you can see there are many methods are here, right? Many way. But here I take only summary of many ways, right? And here you can see test for unit root, label, first difference, second difference, and includes test model. Suppose the first model has only individual intercept, and the second one individual intercept and train, and third one is none. So that means it has three shape. So and here what is going on? If you change it, suppose from here to here, the result will change, and from here to here, result will change, right? So it is very difficult to come to decision when the result will change. Okay, suppose I begin with the individual intercept as a benchmark. That means whatever the result comes from this individual intercept, that result I shall take as a benchmark, that I assume at the very beginning. Okay, then here lag selection, that is another thing. Here I select automatic lag selection. That means EVIEW will find out the lag for me, right? Optimum amount of lag will be selected by EVIEW. Okay, here are many ways. You can see many criteria are here for lag selection. Suppose I choose this criteria, Schwartz information criteria, as a benchmark. Okay, then I am set. I go to summary, and the data is at label and individual intercept. Other things remain unchanged, and then I press enter. So the result has come up. You can see panel unit root summary, and here you can see automatic lag selection, then new west automatic. Okay, and there are many methods, right? Method is here, right? So the methods are here. So many methods are here. We talk about Levin-Liu method, IM Pesaran method, ADF Fisher chi-square method, PP Fisher chi-square method, and the corresponding probability. You can see all the probability are here, and from this probability we can take that decision whether our GDP variable is stationary or not. That we can check from this probability. And from here you can see panel unit root test on GDP. It is already here. Okay, then so many methods. So what is the null hypothesis and what is the alternative hypothesis of all these methods that we should know? Okay, I can check from here. I can tell you from here. So the first one is Levin, Lin and Chua method. Here the null hypothesis is panel data has unit root, and alternative panel data has not any unit root. That means our GDP data has not unit root. Then second method is Brewtang method in the year 2000. Null hypothesis is panel data has unit root, alternative it does not have unit root. Then Pesaran and Sheen method, panel data has unit root, and alternative hypothesis panel data does not have unit root, meaning that the data is stationary. In other words, I can say. Then what about this one? Fisher type test using ADF and PP test, right? According to this, that is assume individual unit root process. Here null hypothesis is panel data has unit root, alternative panel data does not have unit root. So from here you can see Levin, Bretung, Pesaran and Fisher type, all this method null hypothesis is panel data has unit root and alternative panel data does not have unit root. But in case of Hadri, the story is just opposite. The hypothesis has been opposite. Here you can see null hypothesis is panel data has not unit root, meaning that panel data is stationary in null hypothesis, and alternative panel data has unit root. Okay, so this is my all my hypothesis. Now we can proceed about the decision of our variable, which is GDP. Okay, what is our decision? Where is the result? That there's the result. We got it already. Okay, from this result, okay, first I talk about Levin Lu Chut, right? Levin Lin Chu so here is the null hypothesis already mentioned. So the null hypothesis is there is a unit root already mentioned, right? So here the probability value is how much? 1.37%, meaning that less than 5%. We can reject the null hypothesis and can accept the alternative hypothesis, meaning that our GDP variable at at label does not have unit root. So that is the decision in Levin, Lin and Chu model. But what about other method? IM, Pesaran and Sheen method? Null is what? Null is unit root. So what is the probability value? It is 16.03%, which is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that our GDP data has unit root. What about second one? ADF, Fisher chi-square. P-value is 4.96%, which is less than 5%. We can reject null, meaning that GDP data does not have unit root. What about Fisher chi-square? PP method? The p-value is 10.58%, which is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that our GDP data has unit root. Okay, here I can see the mixed result. The result is mixed, right? So actually that is the confusion, because the result is mixed. But the thing is that the result is mixed, that is understood. But the problem is that okay, then you have to choose the benchmark, or you have to choose the majority result. Suppose if all the method or most of the method say that this particular variable has unit root, meaning that that variable has unit root. But if most of the methods say that this particular variable does not have unit root, meaning that that variable does not have unit root. Okay, here we check our cases. According to Levin, Lin, our GDP data does not have unit root, and also Fisher chi-square value, they say that GDP data does not have unit root at label. But on the other hand, IM Pesaran and Fisher chi-square, they are telling that our data, that is GDP, has unit root. Okay, so here is 50-50, 50%. So we are in dilemma what we should decide. Okay, whatever we do, we convert the variable into first difference to check what is going on. Okay, so we can estimate it into first difference because it was at label. Now I estimate it under first difference, right? That I select now, and other thing remain unchanged, and also I select individual intercept because I assume that that is my benchmark to decide. Okay, I press OK. Okay, you can see panel unit truth summary. So here is the data has been converted into first difference. Okay, now you can see what Levin lean to. So now I can reject the null hypothesis, meaning that our data does not have unit root. And what about other three methods? You can see all can reject the null hypothesis and accepting the alternative hypothesis. That means the first difference of GDP data is stationary or does not have unit root, meaning that DGDP, what is it? First difference of GDP does not have unit root, meaning that it is stationary data but after first difference. Okay, we can check also another method that is called Hadri method, and we can see what the Hadri method is telling. So we can check also that what about the method by Hadri, but here make sure all the methods are telling that data has become stationary after first difference. Okay, now I check our another method Hadri, right? So I go to view unit root test, and here I check Hadri, right? Hadri, there is a method, I select it, and first I select at label, right? And individual intercept is my benchmark, right, as before. So I select it, then press OK. So Hadri method, in case of Hadri method, that null hypothesis is data is stationary. That means GDP is stationary. And in case of Hadri method, you can see Hadri Z statistics and consistent Z statistic. Probability is this one, 0, 0, 0, right? Meaning that I can reject the null hypothesis. Meaning that at label, the data is not stationary, right? That means at label the data is non-stationary, right? Okay, then what I do, I convert the variable into first difference, and then I can check as before. I go to view unit root. Okay, now I select first difference, right? And this one is kept unchanged, right? Individual intercept, and other thing remain unchanged. Only I change it to first difference. I enter. Okay. Okay, now you can see Hadri Z statistics and consistent Z statistics. Here the probability value has become how much? 23.3%. Here 5.86%. So they are more than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that our GDP data has become stationary after first difference. Okay, now from here, what is our ultimate decision? That we can write down. Our decision actually that majority of the methods are telling that or all methods, right, not only majority, here is all methods actually are telling that GDP panel data has become stationary after first difference, right? Majority of the methods are telling that, or all methods actually, here in our case all methods are telling that GDP has become stationary after first difference. So that is our decision of these things. But make sure what I want to say here further, I have to say here that if you suppose, if you just a minute, I have to say here further. So if you choose the individual, intercept and trend, and also if you select the none, the result can change, right? Okay, those things you can also select, you can also choose, but the result will change. But what is the ultimate guideline? The ultimate guideline would be you have to take decision on the majority result. Majority, right? Here is the majority is the result, because you shall always get mixed result all the time. That you cannot avoid in the panel root model. So you have to take decision on the basis of majority result, right? And you take that decision. Thank you very much for being with me for a while. Good luck. Bye.